Good morning, students. Myself Janish Shah, Assistant Professor at LG Institute of Engineering and Technology. In today's lecture, we're talking about the insertion in single linked list. There are two different algorithms for that. The first one is insertion at the end, and second one is insertion in ordered linked list. So let's begin. Outlines of today's lecture: insertion at end and insertion at in order linked list. Okay, fine. So let's start with the first algorithm, insertion at end. See, insertion at end of the linked list. So as we all know that in any type of insertion in linked list, we need to return the address of the first pointer. Okay, so here the algorithm return type is function, not procedure, because we need to return address of the first element. Okay, so function ins and algorithm name, then x is the element which we need to insert, and the first is the pointer of the linked list. Okay, so see, what is the first step? How can we get a new node from the availability stack? As we all know, and we already studied in our previous algorithm, that for insertion in linked list, what we need node from which we need node from availability stack. Okay, if this is my availability stack, then I need to fetch out node from that availability stack, because availability stack contains empty spaces in the memory. Got it? So see, this is my availability stack. The very three common steps to get the node. Okay, what are that? The first one is you need to point out the new pointer to avail. Okay, but before that, for insertion we need to check the underflow condition. Okay, because in insertion in linked list, the linked list never gonna overflow. Okay, but if you want to insert something, you need node from the availability stack. But somehow, if your availability stack does not contains any node, then what happen? It is underflow. It cannot give any node. So after that, you cannot insert any element. Fine. So for insertion, what we are doing, we are just checking out the first underflow condition. Underflow for what? Underflow for availability stack. So here it is. The first is underflow. Now for availability stack, underflow condition is if avail is equal to null. See, right now avail pointing over here. Fine. If avail pointing to null, that means stack does not contain anything. That's why the first condition is the availability stack is in this availability stack. If avail is equal to null, then write stack is underflow and return first. Okay. So algorithm is finished from here. But what happens if there is space in availability stack? So the first we need to do is assign new pointer to avail. Assign new pointer to avail. Students, if you remember, if A points to B, then you need to write A arrow B. If P points to Q, you need to write P arrow Q. Again here, now new pointer pointing to avail. New pointer pointing to avail, so you need to write new arrow avail. So the condition, the sentence is obtain address of new next free node, that is new arrow avail. Okay, so now after pointing new pointer to this avail, what we need to do, we just need to remove my avail pointer and pointing to the next node. Okay, if this is avail, if this is avail, then what is the name of this node? Name of this node is link of avail. Got it? So now avail pointer points to new link of avail. Okay, avail pointer points to link of avail. So the step is remove new node from the list. Okay, so that is avail arrow link of avail. Okay, so now students, I get my new pointer, sorry, new node in the memory, such like this. See, this is my new node. This is my new node. Okay, new pointer pointing over here. See, okay, now node contains two things. We all know node contains two things. After getting node from the availability stack, what is the very first step you should do? That is initialize fields of linked list node or new node. How many fields are there? Two fields are there. The first one is data, second one is a pointer. Okay, in algorithm we call data as info and pointer as link. So here we have link and another is info. Okay, so we have info and link. So what we need to do, initialize info of new and link of new. Got it? So next step is initialize fields of new node. Now tell me that at which point we need to insert this node. The algorithm is for insertion at the end. Okay, so if this is my linked list, then I should insert at the end. Okay, fine. Okay, so we all know in simply linked list the pointer of the last node pointing to null. Got it? Pointer of the last node pointing to null. That means we know that link of new must be null. Link of new must be null. That's why, and info of new is x is already given. Okay, so I'm just initializing info of new arrow x. So info of new arrow x, and now I need to initialize this link. I need to initialize this link of new. See, this is the end of the linked list. This node is going to be inserted at end of the linked list. So obviously the last pointer of the node pointing to null, so link of new should point to null. Fine. The statement is link of new arrow null. Okay. So now in this we are going to take three cases. Okay. Okay. If first one is if my linked list is empty. See, I want to insert at the end of the list, but there is no linked list exist. Then what happen? Second one is if linked lists exist. If linked lists exist, then where point I need to insert it, or how can I insert that node at the end of the list? Fine. So let's begin. See, this is the last step that we have seen. Initialize the fields of new node, info of new arrow x, and link of new arrow null. Got it? So next is the list empty? Students, tell me, if the list is empty, then what happens? If list is empty, then first pointer pointing to null, because first is the pointer which pointing to the first node of the list. But here the first pointer is null, that means linked list is empty. If linked list is empty, then whatever the node you get, see, whatever the node you get or you fetch out from the availability stack, you just need to return it. Just need to return it. So this is our first step, very first step, that if linked list is empty, then what we should do, because if linked list is empty, then you just need to return the new pointer. That means new pointer pointing to the very first node. Okay, so this is the only node in the list. If the linked list is empty, then whatever we get from the availability stack, that is only it becomes very first node of the list. Okay, so what you need to do, we just need to return new. Fine. See, this is the first condition. If my list is empty, then what I should do, I just need to return new. Now second condition, suppose imagine the linked list is exist. Okay, see, the linked list is exist. This is the first pointer pointing to the first node of the list. It contains 10, next is 40, next is 50. 50 is the last node. 50 is the last node. It pointing to null. It pointing to null. Okay. Now what I need to do? I just need to insert my new node at end of the list. Okay. See, for each and every operation on linked list, I already told you that first you need to do that gives them name. Okay, assign name to nodes. So what does it mean by assigning name? Assigning pointer to that node. Whatever the pointer pointing to that node, that pointer becomes its name. Okay, as per example here to this node, see, focus on the mouse pointer, that on this node new pointer is pointing over here, so name of this node is new. Again for this node first pointer is pointing to here, name of this node is first. For this node 40. Okay, which pointer is pointing to 40? See this link. Okay, so it means that link of first pointing to 40, link of first pointing to 40. So if this is first, then this node becomes link of first. This node becomes link of first. So these are the name assignment to the nodes. By using this, we are going to insert node at the end of the linked list. Fine. So first, what we need to do, I just need to assign the save pointer to first, because I need to insert the node over here. Okay, for that I need name of both nodes. See, I just want to connect this node to last node. Fine. Name of this node is new, but what is the name of this node? 50. What is the name of node 50? Do we have any name? No. Please don't say, sir, it's link of first or link of first, because right now in figure you can see it very easily, sir, because linked list contains only 3 elements. But what happened if the linked list contains 50 or 100 elements? Okay, you cannot write like this link of link of link of link of. Okay, for that you need an extra pointer. You need an extra dummy pointer, and that dummy pointer is known as save over here. Okay, fine. So save is a dummy pointer by which we can move save to the end of the node. Okay, so see, first we need to initialize save to the first. Assign save pointer to first. Okay, because we need to reach save to the end of the linked list. Okay, so the first step is initialize a search for the last node. For searching the last node in the singly linked list, we are just assigning the save pointer to the first node of the linked list. So the sentence becomes save arrow first. Next, what we need to do? We just need to move this save pointer to forward. See, I just need to move save to 40, then save to 50. Okay. Now tell me, what is the link of last node? Where the link of last node pointing to? The link of last node pointing to null. So when this save, if is this save, then this becomes link of save. So this is a link of save. Okay. So now I'm just continue with the algorithm that see, save pointer pointing to the first node of the list. Okay, save pointer pointing to the first node of the list. Now tell me, is link of save is null? No. So save pointer should move forward to the next node. So see, if this is the save, then this becomes link of save. So node name of this node is save and name of this node is link of save. Fine. So what happened? We need to move save pointer to the next node, save pointer to the next node, and that node is save pointer pointing to the link of save. Okay, so what is the statement? That save pointer should point to link of save. See, save pointer should point to link of save. Okay, so students, repeat while link of save is not equal to null. So first check the condition. Okay, see, right now save pointer pointing over here. Okay, and link of save is null. See, check, is link of save is null? No. Okay, so what we need to do, we just need to move save pointer to link of save. So I'm just moving save pointer to link of save. See here. Now again check, link of save is null. See, link of save is null. No. Link of 40 is null. No. Okay, so what you need to do, we just need to move forward save pointer to the link of save. See, save pointer to link of save. Save pointer pointing to 40 and link of save is 50. So link of save becomes over here. Fine. So now again loop is going on, and we need to check link of save is not equal to null. See, is link of save is null? See, this is save, then this is link of save. Now link of save is null. Link of save is null. That means you should stop from here. Okay. So now tell me, what are the name of the both nodes? Name of this node is new and name of this node is save. Name of this node is new and name of this node is save. Okay, so now we get name of both the nodes. Okay, so we can connect easily. Okay, what we need to do, if I want to insert this last new node to the end of the linked list, I just need to connect link of the end node to the new node. Okay, fine. This is my new node. This is my new node. This is my last node. This is save. This is new. This is save. This is new. So link of save should point to new. So what is the last step is, link of save should point to new. This is the link of save, null removed and pointing to new. Fine. Okay. So such like, and what is the last step? We need to return the address of the first node. Address of the first node. Now tell me, what is the first node? First. first only. Okay, so just write return first. Clear? See students, to move save pointer from one node to the last node of the list, from the first node to the last node of the list, this procedure is known as traversing in the linked list. Because traversal, that means a operation of any data structure in which, again repeating this sentence, traversal, it means operation on any data structure in which we need or we get access of each and every data element at least once. Okay, if you access each and every data element of the data structure at least once, that operation is known as traversing. And to move save pointer from the first node to last node, this operation is known as traversing in singly linked list. Okay, so just watch this video more than 1 or 2 times and get the better idea that how can we move save pointer from first node to last node, and how can we insert in singly linked list at the end. See, the insertion in linked list is very much easy if you figurize its image in your mind, that how the node should be inserted, or what is the, you just need to imagine the position of the node. See, I'm just drawing it on my canvas sheet that this is my last node, this is my linked list. I need to insert at the end of the linked list. So what I need to do, I need to connect the last node pointer to this node. Fine, I need to connect last node pointer to this node, so I need name of both nodes. So I just take first save, do traversing in single linked list, assign save to the last node, and give it link to the new. Got it? Fine. Still, if you have any doubt, then please feel free to ask me. Till my next lecture, please stay safe and keep smiling. Thank you so much.